All right, so I know we just went over this on the previous video, but I just want to reiterate before we go over all this stuff that remember torque is a force that makes something rotate, and the equation for torque this is the Greek letter tau for torque, and that's how far away the radius the force is being applied times the actual force times the angle, the sine of the angle, between the lever and the actual force that's going into the lever. Okay, so this is our equation for torque right here. So let's go ahead and kind of see how this actually helps us solve some of these. So in our first problem, we have a 4 Newton force, and force F is applied to a bar that can pivot around its center as shown below. So there's this one in this problem is this force is equal to 4 newtons. Okay, the force is perpendicular to the bar and it's 0.25 meters away. That's what R is. Okay, so what we know here, now we can plug all this stuff. And by the way, the angle right there, remember this is the angle between this force and this radius, right? So that's a 90-degree angle. So when I plug all this stuff in, I would have torque is equal to a radius of 0.25, right? A force of 4 newtons, and the angle, sine of 90 degrees. Well, 90 degrees, remember, this is just 1, right? Sine of 90 degrees is equal to 1. So this just kind of disappears, becomes invisible, right? So a fourth, 1/4 of 4 would give us 1. And then our units are going to be a Newton times a meter. It's the typical way we write it. And some of you might be saying, oh, that looks like work from energy. Same units, different type of thing, because now we're talking about rotational motion. So yeah, that's how it's done, right? Really, the only thing that's going to be weird with some of these is, like in this problem, the angle changes a little bit. So on this one, we have a 25 Newton force. So this is now 25 newtons. It's applied to this bar that can pivot. So right there, that big black dot is the pivot point. The force is 0.75 meters away from the pivot point right there. And then this angle, right, they tell us is 45 degrees. So from here, we just need to use our torque equation. If I want to calculate the torque, remember that's R, F, sine theta. And so now when I plug and chug, I have, and nothing quick about this one, you just need to plug it in your calculator. Make sure when we're doing angles like this that we're actually in degrees. Okay, and then our answer ends up being approximately, after a little bit of rounding, 13.26 Newton meters. What does that mean? That is the torque. That is the rotational force that's happening, the amount of force that would be trying to make that bar start rotating. Okay. One more example. What if, this is another type of one that we could come into. We had the first example, which was perpendicular to the lever arm. Then we had our last example, which was just some random angle, right? What if the force is totally parallel to the lever arm? All right, so we have a 25 Newton force, so that's that force right there. It's applied to the bar so it can pivot, so its pivot point is right over here. And then the force is parallel to the bar. So here's the deal. Think about a door. If you pushed parallel to the door, it wouldn't go anywhere. And so that comes into play in our equation with this sine of theta piece, because the angle between my lever arm and the force right here, if they are parallel, that angle between those things is 0. There's my lever, there's my force. There's no angle between them. They're the exact same thing. So the sine of 0 degrees is equal to 0. So if this turns into 0, right, that's RF times, if this turns into 0, that's RF times 0. So this entire thing now just goes away to 0, right? So if your force is parallel to the bar, then that's like, we don't even really have to do a whole lot of work. We just know that the torque is equal to 0 Newton meters. Alrighty? So all of the other torque problems really just are similar to those three situations. You got perpendicular, you got parallel force, and then you have just some other type of angle there where you just plug in theta. Alright? I will see you guys later.